In this video, I'll talk about a problem related with the Hooke's law. So here we have given a spring and which stretches by 20 centimeter when 150 Newton object is loaded onto this one. So let's say if this is 150 Newton, then this elongation is 20 centimeter, and this line here means the position without no mass. That means if I just take this mass off, then the spring will come back to this position. So all the measurements are done from this line here, so when there is no mass. And this with the mass, this is what we call the elongation or the stretch in the spring, or we simply call x, or the displacement. And in order to calculate the spring constant by given force and the displacement, we're going to use the Hooke's law. The Hooke's law tells you the force is equal to minus k times x. K is called the spring constant. This is the spring constant, which is a constant for a spring. It does not change if you have the same spring. What changes is the force and the displacement. If we apply more force, then the displacement will be more. But K, the spring constant, will remain exactly the same in most cases. Okay, so what is the negative sign here? So let me explain a little bit about the negative signs, although it is not relevant for this topic, but I will explain anyway. So there are two forces acting onto this spring, into this mass. The one force is the weight, its weight, which is mg, and the spring tries to pull it back. So there is this force here. This is called the restoring force, or the force by the spring. That's the restoring force, which is opposite to the applied force. Or if the displacement increases, the more we pull it down, the more will be the restoring force. That means the restoring force and the displacement are in opposite direction. That's what does the negative sign means here. Okay, if we do not need use the negative sign, if we just use F, then that means this is the applied force. Okay, with the negative sign, that means the restoring force. Anyway, so now let's get back to here. The magnitude of this force would be simply K times X, and we have to calculate K as it is asking here. What is the spring constant? So K will be simply force divided by the displacement. The force is already given, which is 150 Newton, and the displacement is 20 centimeter, and you have to change the 20 centimeter to meter. So just divide it by 100 and it will be 0.2 meter. So we have calculated the spring constant, which is 750 Newton, or Newton per meter. The unit for K will be Newton per meter. This is Newton and this is meter, so it will be Newton per meter. The second part, what it's asking here is, what is the stretch in the spring if 20 kilogram object is hung from it? So now we are given a different mass now. So what happens, or how much will be the elongation in the spring? So let's calculate this one. The first thing we need to calculate, what is the weight of the 20 kilogram object? So this is the mass, which is 20 kilogram. The weight or the force is equal to m times g. The mass is 20 kilogram. G is 9.8. So the force we are applying is now 196 Newton. Again, this is a Hooke's law. Force is equal to K times X, and I'm simply using the magnitude of the force. And so K will be force divided by X will be force divided by K. The force is now 196 Newton. And K value, as I mentioned, K does not change. For a spring, it remains the same. The only thing that changes is the force and the displacement. K remains the same. So I already have calculated K, which is 750. Now if I divide, what I will get is 0.26 meter. That corresponds to 26 centimeter. Alright. So this is how you use the Hooke's law to calculate either the displacement or find out the spring constant of a spring. So this is it from the Hooke's law. Again, if you have any questions, any comments, any suggestion, write down in the comment section below. And do not forget to like, share, and subscribe the channel.